Today we're going to learn about generation of uh, delay in assembly code as well as C code. Then we're going to learn about this one of this 8051 special function register, which is we call it timer and counter. However, I'm going to deliver the lecture on a counter in a separate video lecture. Okay, why we need delay? In fact, delay subroutine in any embedded application is the most widely used in many applications. Looking on the application itself, there are so many applications that require generation of a certain time of a delay. It is either a very accurate delay or just a random time delay. Taking traffic light as one of the common example that we can find anywhere in the Earth surface. Um, Looking on the traffic light which has pedestrian crossing, okay, uh, a person who want to cross the road are required to press a crossing button, and then after a certain time or immediately after he or she press the button, the pedestrian light will turn to green from red, allowing the person to cross the road. Meanwhile, the road traffic light, of course, will turn from green to amber and from amber to red to ensure or to command or to give a signal or to give an indication that a vehicle are required to stop at a certain time. So, how long that a pedestrian green light will stay on? This is achieved by the generation of a time delay. If the person are fast enough or walking fast enough to cross the road, it might take a shorter time delay. If the person are crossing very slowly, it might require a longer time delay. So let's say the green light will hold about 5 to 10 minutes to allow various type of walking pattern to cross the road. That is one example. Another example, if we look on the industry perspective or industrial application, like a water filling station. So how long does the station or the water filling process required to fill the bottle? So it is again can be achieved using a time delay. It is either using unknown time. Sorry, it is either using a not accurate time delay or a very precise time delay. um, so in this lecture, we're going to discuss two type of time delay, whereby the first one is pure software time delay, and the second one is the special function register, or we call it a hardware version of 8051 timer. Okay, we have done some exercise before about running light or a night rider, whereby we have 8 LEDs in a row, and then when the first LED is turned on, then it's off, followed by the second LED is on and off, followed by the third LED is on and off, and followed by the fourth, 5, 6, 7, and 8 LED, and then after 8 LEDs and off, 7 LEDs turn on and off, and so on. So the transition between on and off between each LEDs is also required a time delay. Okay. In more precise, if we look on our previous exercise of a Knight Rider, we have the main function, and within the main function, we declared that the LED is located. We declared the LED is actually on the port 1 of 8051, and between the transition, actually, we call a delay function. When we call a delay function, it will go to the respective delay function. In this structure, it shows how the process look like. Okay, whenever we have a main function, if we have another function calling, it will go straight away to the respective function. And if in the first function got another calling the second function, of course it will go to the second function. It apply both on C as well as assembly code. On assembly, if we look on the first column, whereby the first column is actually what it says, this is a label. Okay, and the second column is the instruction. So when this is the main function, this is the main function. So whenever it's calling the loop, it will go to the loop. Okay, this is how it goes. If like this, a jump interrupt, so it will go to interrupt, and after finishing the interrupt subroutine, it will go to the where it stopped and the next line. Okay, it's same happen to the delays, either software delay or even a pure hardware delay. Okay, recall some knowledge about your electronic knowledge. If you still remember, there are a special IC that capable of generating a time delay, that we call it a 555 timer IC. It is capable to generate delay by using a combination of the combination of a resistor and capacitor. If we want a specific time delay, we have to find the combination of the resistor and capacitor. However, using this method, the design will be very specific. We cannot have a dynamic design whereby within the program we have to generate a various time delay. For example, at certain time we need to generate a 10-second time delay, and then after a few seconds, and after a few minutes we need to call 20-second time delay. So using a 555 timer is quite difficult, it's quite tricky, or even the development sizes become bigger and bigger. Okay. So one example, in fact we have done it so many times in class. Okay, find the delay size or the time delay subroutine in the following program if the crystal frequency is 11.0593 megahertz. So it's actually want to calculate what this question is asking is actually want to calculate the subroutine of time delay. So here move 200 R3 is actually move the value of 200 to R3. Bear in mind is 200 here is a decimal value of a decimal value that will be put on in R3, and then DJ and Z 200 R3 is a decrement jump and not zero R3, and then return. Okay, move for the first time in this line, the value of R3 will be copied on the register number 3, and then on the second line, its decrement jump not zero, it will check whether the value of R3 it is either 0 or not. If it is not 0, it will decrement by 1, and if it is, and it will jump to the label, which is here. Okay. However, if it is 0, it will go to the next line, which is return. So it will return to CPLA. So now we want to calculate how long this time delay subroutine is generate. Okay, having known that the formula is 1 time 12 over the crystal frequency, looking at the 8051 numeric table, we know that move function or move instruction having one machine cycle. So 1 times 12 over 11.0592, we've got 1.085 microsecond, and DJNZ 200 R3 is, because this is the machine cycle is 2 times 12 over 11.0592. However, now it doing this line 200 times, so we have to multiply it by 200, so we have 434.03 microsecond, and return the machine cycle of return is 2 machine cycle, so 2 times by 12 divided by 11.0592 equal to 2.17 microsecond. So the total is just total up all these three results, and we've got 437 microseconds. So this is the amount of time that is generated by this subroutine of time delay. Okay, thank you very much. We will continue the lesson in the next video lecture. Thank you very much.